All right. Well, hi, good morning, good afternoon, everyone. Welcome to our webinar in partnership with Climate Central. Today, we will be talking about king tides and how they are affected by a warming world. My name is Pearl Marvell. I am the features editor here at Yale Climate Connections. YCC is a news service that helps you understand the reality of climate change and what you can do about it. And through our website and social media platforms and radio program, we reach millions of people like you each year. We are staffed by journalists, meteorologists, radio producers, and are fortunate to be part of the Yale program on climate change communication. YPCCC is made up of a group of psychologists, geographers, political scientists, statisticians, pollsters, and communication scientists who study beliefs and opinions about climate change at both a national and international level. And today we are joined by Dan Rizza, who leads the program on sea level rise at Climate Central, an independent group of scientists and communicators who research and report the facts about our changing climate and how it affects people's lives. Dan directs a team dedicated to equipping coastal stakeholders with the tools and information and products necessary to understand, communicate, visualize, and respond to sea level rise and coastal flooding, while also underscoring the importance of mitigating its drivers. Thank you, Dan, for being here with us today. We also have the pleasure of having John Morales with us. John is a certified broadcast and consulting meteorologist in South Florida and has served as a reassuring television presence for 34 years. He has guided his South Florida viewers through Hurricanes Andrew, Irene, Katrina, Wilma, and Irma, and was vital to drawing awareness to the enormity and severity of Hurricane Maria as it approached Puerto Rico. YCC contributor Jeff Masters is also here and has worked as a hurricane scientist with the NOAA Hurricane Hunters. After a near fatal flight into a Category 5 Hurricane Hugo, he left the Hurricane Hunters to pursue a safer passion, earning a PhD in air pollution meteorology from the University of Michigan. And in 1995, he co-founded the Weather Underground and served as its chief meteorologist. And between 2005 and 2019, his Category 6 blog was one of the internet's most popular and widely quoted sources of extreme weather and climate change information. And we are now lucky to have him here at Yale Climate Connections covering extreme weather throughout the US and beyond. Thank you to the three of you for being here today, and we look forward to diving into king tides. So king tides is a term used to describe an exceptionally high tide, but how does climate change fueled sea level rise affect these tides? And are king tides a preview to the climate future that we face? Today, we will find out the answers to this question and more, and we will be watching the chat for questions. And in the last half of this conversation, I will pose some of these questions to our venerable guests. For the last 5 minutes or so, Climate Central's weather and climate engagement specialist Shel Winkley will give us a recap on how extreme heat affected millions around the world this summer. And we will also have two slides at the end of the presentation with QR codes for our newsletters, including Climate Central's, and our Spanish language WhatsApp channel. So please sign up if you haven't already. So my first question is for Dan. Can you give us an explanation of what are king tides exactly, and why should we be worried about them?
Well, thanks, Perla, for having me and for organizing this. King tides are the highest seasonal tides of the year, caused by the predictable alignment of the sun, moon, and the earth. I'm going to share my screen here so that you can see some of the visuals that we got of king tides from local officials in St. Augustine that we've been in touch with. So these happen a few times a year, often in the fall in the East Coast, and then in the winter on the West Coast. So they've always been part of our coastal systems. They're natural events, but what's different today is that climate-fueled sea level rise is stacking on top of these tides and making them higher and more disruptive. Along many U.S. coastlines, relative sea levels are rising, have risen approximately 8 to 12 inches over the past century, with higher or lower rates in some areas, and a large percentage of that rise comes from human-caused warming. So the tide itself is natural, but the baseline it starts from is higher than it used to be. I'm also showing you some other visuals we got from Miami-Dade officials. It's important to know that a few inches of rise can make a big difference. Officials in Miami-Dade tell me that one of their tide gauges that they've been tracking has shown recent acceleration of rising seas, about 5 inches of sea level rise since 2009, almost half of the increase of the previous century. And that when people hear 5 inches, they often think that doesn't sound like much, but those inches are the difference between a wet sidewalk and water in your garage or living room, according to these officials in Miami-Dade County. Across the US, Climate Central's analysis found that climate change has already influenced a large percentage of tidal flooding in the past decade. So these are floods that don't require storms, but still close roads and damage infrastructure. So a lot of the human-caused sea level rise are making these much worse. What used to be rare is becoming more routine. So what's causing sea levels to rise? As the planet warms due to carbon pollution, oceans warm as well, and seawater expands. So this thermal expansion historically has been the largest contributor to rising seas. And then on top of that, a warming climate causes glaciers to melt, and these massive ice sheets in Greenland and Antarctica are flowing into the ocean, which is causing seas to rise as well. The rate they're disintegrating and flowing to the ocean is accelerating, and scientists are keeping a close eye in particular on the ice sheets in Antarctica and how fast those outlet glaciers may flow into the ocean. I remember working with scientists back in 2004 when they were starting to look at the outlet glaciers in Greenland that were accelerating and moving into the ocean 2 or 3 times as fast. So this is something that's evolving, and NOAA and other agencies project 10 to 12 inches of additional sea level rise by 2050. It's also worth noting that in some regions like the Gulf Coast, the land itself is slowly sinking, which is making relative sea level rise faster there. I was recently at the Florida Resilience Conference, and officials there told me that people often see water recede from these king tides after a few hours, and they assume it doesn't matter. I'm showing you additional visuals from St. Augustine, but those few hours can disrupt entire days. Roads become impassable, salt water can damage vehicles, and businesses need to close. So this is really on the minds of the St. Augustine officials who gave me these visuals from king tides that are happening that happened last year. And the king tide season is afoot in St. Augustine right now as we speak. So residents, we've heard this from various government officials and from interacting. Often residents sometimes think the city isn't cleaning its storm drains when they don't empty, and they're not sure why water is accumulating. But many stormwater systems rely on gravity. So if the tide outside is higher than the drain's exit point, the water can't flow out. And I also know that rainfall exacerbates tides as well by high water levels of tides. Even moderate rainfall can't drain effectively, so water accumulates faster and lingers longer. So with that tide, surge, and rain, you have compound flooding, and it's one of the biggest challenges for coastal planners. We already see cities. And so king tides can also give us a glimpse of the future. They show what regular high tides could look like as the baseline rises. Tidal flood days overall are increasing in many parts of the country. For example, officials in St. Augustine told me that they currently experience 12 to 16 tidal days each year, but by 2040, they could have up to 26 flood days, or even by 2070, from 30 to over 100 tidal flood days per year, depending on how fast sea levels rise. There's some good tools out there. NOAA's sea level rise calculator is a good one you can go to, search for your closest location, and see how flood days are increasing in frequency. You can see Fort Myers here. You can see how flooding was rare in the 1980s. And then by 2050, the projections are much higher, 40 to 100 flood days per year, depending on emissions and sea level rise. So king tides and tidal days will be increasing over time and disrupting roads and businesses and daily life. There's another good resource here. NOAA has this co-ops tool, which lets you visualize when and where higher than normal tides and high tide flooding are most likely up to a year in advance. And so we can put this URL, you can see the URL there at the bottom of the screen. We can put that in the chat. And that's a good resource for you as well. And we've developed a couple of resources at Climate Central that can be of use. Our Coastal Risk Finder tool here is a screening level tool that helps you visualize and plan and provides localized flood projections and helps you understand who and what is at risk. And you can search for locations and view solutions of what states are doing and how they're responding, and how different users are using our tools, like government officials or community leaders. And we've also developed Flood Vision, which is a technology that creates photorealistic street-level flood visualizations, along with entry floor elevation data. We recently partnered with the Northeast Florida Regional Council to visualize what future flood scenarios could look like. And we were actually able to plug in annual flood levels, which can approximate king tide levels. They also had precipitation models and that we plugged in that are really meaningful for their vulnerability assessment work. So we're able to help communities and government officials visualize what flooding could look like in the future based on different scenarios. And officials from Miami-Dade have told me that impacts can extend far beyond the shore as well, because water can't drain out when the bay is already full. Even neighborhoods far inland, they tell me, can see flooding back up from the coast. And they say that this means septic tank systems can also fail, for example, when groundwater rises, creating health issues, also mental health challenges as well for residents. And the resilience costs can be pretty expensive. One Miami-Dade conversion project is spending about $20 million to move 340 homes from septic to sewer. And that's a sign of how costly adaptation can be. So king tides are predictable natural events, but they're being worsened by rising seas, turning rare floods into more routine ones. And they offer a preview of tomorrow's floods and a reminder that our choices today, whether that's investing in resilience or reducing carbon pollution, can determine how severe those floods become. So I'll leave it there, but happy to continue the discussion later.
Thank you, Dan. I appreciate that. And yes, so we are going to go on to John. My next question is for you. Research has found that Americans living in coastal communities primarily view sea level rise in particular as a problem for other communities, not their own. Even when they're shown flood maps of their own properties and how they might potentially be flooded in the future. In your years as a meteorologist, what has been your experience trying to relay this very real danger? And currently in South Florida, you're experiencing these king tides. How have you been communicating with your audience about that connection between sea level rise, climate change, and king tides?
Well, thanks, and good morning, everyone. Well, I mean, king tides have been a phenomenon that's been around in South Florida, of course, for decades or centuries, for that matter. In the urbanized part of the city, though, there are archives in the Miami Herald that show how this water was confined to, just a couple of corners, within Miami Beach, for example, one of the more flood-prone areas for these sunny day floods that happen even when it hasn't been raining. I'll point out, by the way, that the picture selected for this event is a Miami Beach picture, as people are trying to leave a hotel and find that the entire street is flooded with salt water. What's happened is that we've seen the footprint of the king tide of this saltwater inundation expand to many more blocks in Miami Beach, many more neighborhoods in South Florida, from Fort Lauderdale to Coral Gables to Coconut Grove to Miami proper, very close to downtown Miami. You see this type of flooding happen too. So to answer your question, how do I communicate about this? Well, it's become easier to communicate about it because it's affecting more and more and more people. Like Dan said, it's a picture of what the future might look like. And it's always important to communicate, hey, it's not that we're going to have water lapping up on the Art Deco buildings of Ocean Drive in South Beach, every single day of the year and destroying those buildings in a cataclysmic type of event. Think extrapolations on Apple TV, right? It's not that. It's the fact that the number of days in which this flooding is affecting us is expanding. And more days of this leads to more and more infrastructure problems, more of the problems that Dan pointed out. Now, let me go ahead and share my screen because I have some things that I want to show too. And I'm going to start with this one. This was shared by Brian McNulty, University of Miami researcher, where he basically stated, I haven't seen anything like this in terms of the prediction of what would be happening during this particular king tide cycle here in South Florida. So the red line is the NOAA prediction. But this NOAA prediction of how high the tide would get during this particular king tide cycle is based on the epoch, which I think is 1984 to 2001. So it's basically outdated. It basically does not account for sea level rise, which has happened since. So then you look at the yellow line. So you add on top of that the expected tide, taking into account sea level rise. By the way, sea level at the Virginia Key tide gauge, which is right here in Miami, is 6 to 7 inches higher today than in the mid 1990s. So when you hear folks telling you, oh, but sea level has risen 8 inches in 100 years, what's the big deal? Well, let me tell you, it does not happen evenly all over the world. Some places get much more pronounced sea level rise or king tides for that matter than others. And Miami is one of them. And we can get into some of the reasoning behind that. But let me just show you a couple more things. Here's how one neighborhood is dealing with it. They have a pump pumping water out of the drainage to make sure that the street can remain dry. This is in a neighborhood in Coconut Grove. And what does that look like in terms of actual measurements? Here is the latest up to this morning. And you can see that the observed tide, this is at Virginia Key where I mentioned, was 1.18 feet, right, above the prediction. And, that's not chopped liver. 1.18 feet above the prediction. You can imagine the types of problems this is leading to. Obviously, based on the National Weather Service graphic here, this would lead to moderate flooding. We're not quite at the major flooding part yet, but here's perhaps a chance for that to happen down the road. I should point out that this isn't just king tide combined with sea level rise. There is an onshore wind flow going on here right now. So some years are not going to be like this. Some years there will be an offshore wind flow, and it will not be as bad as we're seeing it develop this year. Now, what does this year look like? Let me show you a couple of pictures of that if I can figure out how to get back to where I was. Stop share, and I'll share something different here. Or at least I think I will. Here we go. So, here is basically a park with a park bench that the water is nearly to the part that you sit on. As you can see, it's inundating the entire area nearby. And I do apologize for the quality of these. These were grabbed off of Instagram, just screen grabs. But here's an entire street flooded from what's going on. And I'll have one more thing to share, and let me stop sharing this one and share one more here, because what I want to point out while I share this slide is the lived experience of some people that I know here in South Florida, which are really having a difficult time dealing with what is going on. And how come I can't find what I'm looking for now? Well, let me start telling you. I have a friend, very rich friend, lives in he lives in Key Largo, and he has a beautiful house that is up on stilts because, of course, there's also storm surge to be concerned about. This house up on stilts, however, has become inaccessible several days of the year because you can't get to it because the road is blocked by deep water. He changed his vehicle from a sedan to one of these big Jeep-like things with the huge wheels, lifted and with a snorkel instead of a muffler to be able to get in and out of his house. There are some neighborhoods in the Florida Keys which several days of the year are basically inaccessible and where services from Monroe County, which is the name of the county where the Florida Keys are impossible to deliver. This includes, trash collection and such, because they're underwater during so many days of the year. The Florida Keys, by the way, will be the first to go. When people think of, oh, Florida is going to be underwater. Well, you know what? Not all of Florida is going to be underwater. But you know where it's going to start? It's going to start in the Florida Keys. So I haven't even mentioned storm surge. But these folks in Western Florida, in the Gulf Coast of Florida, that have lived through Ian, Helene, Milton, Idalia, Debbie, and some of these other recent hurricanes that just in the last 3 or 4 years have impacted the west coast of Florida, their storm surges have been deeper and more far-reaching due to sea level rise. So you want to know how when people will become alarmed? Is when they realize that the storm surge from a hurricane is worse than what it was before. I think this was mentioned just before we got started. Think of that picture that went viral years ago of an octopus that came up through the drains of a parking garage of a condo in Miami Beach, of a condo building in Miami Beach. To me, that's the novelty phase of sea level rise and king tides. But here in South Florida, we're not just at the nuisance phase where it's blocking streets, where our cars are getting rusted out, if we happen to drive through those streets, where, like Dan correctly pointed out, the number of days in which we see urban floods from rainwater is multiplying because the water table is now higher because what sits below us is not bedrock. It's limestone, therefore it is porous. Therefore, as the sea is surging around the Florida Peninsula, it is pushing the water underneath our feet higher. The water table is higher. There is less room to store that water. Compound that, of course, with urban sprawl and all the other problems with the runoff that we have. We're even past that. We are at the lifestyle and pocketbook phase of this. Why? Because it's impacting insurance rates. Because in Florida, flood insurance has become, with the new iterations by FEMA of the flood zones and by the National Flood Insurance Program of how much it's going to cost you, there are parts of Florida where people have basically had to consider selling off their property or finding a way to get rid of it because they can't pay the new flood insurance rate. And perhaps rightly so, because these houses shouldn't be there in the first place. When we get to the existential part, well, that's down the road. But by then, the pocketbook and lifestyle issues are going to be rampant, and it's going to impact all of us. So I've said a lot. I think I'll stop here, and then we'll open it up for questions later.
Thank you, John. That is such amazing insight. Yes, so my next question is for Jeff. We touched upon it a little bit with what John was saying, but can you tell us a bit more about some of the most extreme cases of a combination of a king tide with a storm or, potentially onshore breeze that has done extensive damage? And can you also tell us how this all has an effect on coastal properties and communities?
We have a case coming up probably this weekend. We've got a coastal storm developing along the U.S. East Coast that's going to drive an onshore wind. And we're forecasting in Charleston, South Carolina, major flooding on Friday's high tide cycle because of this, no-name storm that is going to be pushing water onto the coast in combination with a king tide, highest tides of the year. So that's just one example. We had an example back in 2020 from a hurricane called Teddy, major hurricane category 3. It passed 1,000 miles offshore from the US, but it drove big swells into the coast and caused major flooding 3 or 4 different days of the year along a large stretch of the coast from Florida through Georgia through South Carolina. So you don't even have to get a storm. As John was saying, just an onshore wind will do. And a high pressure can do that too. We got a pretty strong high pressure right now over the Northeast, driving an onshore wind, and we're going to see moderate flooding in Miami today because of that. So in combination with the king tides. So if you show the first slide for us, Pearl, the poster child for an extreme storm at the time of a king tide is Hurricane Sandy of 2012. Hurricane Sandy drove a 9-foot storm surge to New York City. It's about 2.7 meters. And it happened during one of the highest tides of the year, a king tide. And because of that king tide, the water levels were about a foot higher than they would have been during Hurricane Sandy's storm surge. So, okay, you say a foot extra storm surge compared to 9 feet, that's not a big deal. But Climate Central did a study after Sandy and determined that the last 4 inches of the storm surge, 10 centimeters, did about 8 billion of its 62 billion in damage. So that's not chump change. It doesn't take much extra water once you exceed a certain threshold to cause a lot of damage. And a good example of that is if you get an inch of water in your home. FEMA estimates that just 1 inch of water in a 2,500 square foot home will do about $27,000 in damage. But if you get a foot of water in your home, then the damage jumps up to about $72,000. So just a few inches makes a huge difference. And king tides, when they happen to coincide with a storm coming or a hurricane, in the case of Sandy, that's going to really drive a ton more damage. So if you go to the next slide, please, Pearl. Let's talk about another part of the moon's orbit that we need to be concerned with. It's not just king tides. It turns out that the moon has an 18.6-year cycle. So the tide never repeats itself exactly except once every 18.6 years because the moon kind of wobbles in its orbit around the Earth. And it turns out that right now, the moon's wobble is such that you're not getting a ton of extra sea level rise along the US southeast coast. But come the mid-2030s, around 2035 to 2038 or so, the moon's wobble is going to be such that it's going to drive a sharp acceleration of sea level along a big stretch of the US coast, both in the southeast, the Gulf Coast, and the West Coast. And you can see these 4 plots I did here using NOAA's fancy sea level rise tool, showing that, okay, sea level is just kind of gradually increasing because of climate change over the next decade or so. But look how it ramps up very suddenly in the mid-2030s at all these locations. So I plotted here one in Florida, one in Galveston, Texas, and then over on the West Coast in San Diego, and then in the Mid-Atlantic coast in North Carolina. So all these locations are going to see a big jump in king tide flooding, high tide flooding, sunny day flooding, starting in the mid-2030s. And that's going to drive a lot of pressure on the coastal real estate market, which is going to be hard pressed to keep up with the demand for people wanting to dump their properties and move elsewhere. Next slide, please. And as I alluded to, people are going to be wanting to move because we have a coastal property bubble. The overvaluation from flood risk along the US coast is hundreds of billions of dollars. And when we stop playing this game of musical chairs and the music stops and everyone wants to unload their property at the same time, we're going to see a big readjustment in coastal property values when this bubble pops. It is guaranteed going to happen. It's probably going to happen earlier than the 2030s, as John alluded to, because we have an insurance crisis going on right now. You're going to see people unloading their property because they can't pay for insurance. So that's all that I have right now. And Pearl, back to you.
Thank you, Jeff. I appreciate it. So now I actually want to jump directly into the questions that we've been receiving because there's so many great ones. One of the first questions we received was about the tools that NOAA has. Have they been affected at all by the defunding that has been taking place since the beginning of the Trump administration? And that is for anyone who would like to answer that.
I can speak to that. We were in touch with those folks because we're dependent on some of their data sets. And we were concerned, but it looks like a lot of the sea level rise tools and flood tools are still online. A lot of the staff members behind them are still there. There was one that was taken off the federal flood risk management standard related tool that helped agencies determine kind of climate sea level rise informed flood elevations for various reasons. That one's offline. And actually, I should mention that I was on the sea level rise calculator yesterday preparing for this, and it didn't seem like the full functionality was there. Perhaps that's because of the government shutdown. I'm not sure, but in general, they seem to be running. I should say.
Let me add to that. There's a website called globalchange.gov, which hosted the National Climate Assessment, which was taken offline. And one of the tools they had at that website was a sea level rise page, which I had used in the past. And I was involved in another webinar a few months ago where somebody had a question about for a specific city, what was the expected sea level rise? And I knew that this tool was out there, but that very day was the day that the administration took down that tool. So I wasn't too happy to go to, what I had used before and not been able to do that. So that's one example of a sea level rise tool that's gone now.
Yeah, it's interesting times. And a lot of these tools are dependent on a lot of data sets. So if certain data sets are taken offline, then tools can't function properly. So we have to keep an eye out.
Yes, we do. All right. So another question we received was pumping stations seem to be the go-to choice for many coastal cities to mitigate flooding. But with compound funding happening more frequently and at times more severely, waterways and rivers are at capacity. Should cities be looking at more innovative measures to deal with severe flooding issues? John, I know in your recent post, you talked about pumping being the kind of Band-Aid for this type of flooding. I didn't know if you wanted to add a bit more to that.
I have plenty to add. First of all, I mean, talk about a carbon tax, right? You know how much money it's going to take to adapt to this sea level rise? So, you remember back in the day when people were floating the idea of a carbon tax, which is still very much needed, to tax fossil fuels. Well, folks, taxpayers are paying for this regardless, because if we continue to inject greenhouse gases into the atmosphere, sea level rise is going to accelerate. It's going to the water will continue to come faster. And a lot of this is already baked in, right? But we can try to slow it down so that we have more time to adapt and take some of these measures. Now, Dan, I believe, showed a slide in which it showed how the drainage leads into the bay or into the ocean. And when sea level rises, that water backs up instead and comes up the drainage and onto the streets. One of the simplest solutions is to have a backstop to that so that the water can only flow one way. It can only go out. It can't come back in. And that's, relatively speaking, I mean, you still have to dig all that up and whatnot, but it's a relatively less expensive solution. More expensive solutions include what Miami Beach has been doing. The municipality of Miami Beach has been raising roads, in some instances as much as 2 feet. Then we're talking tens of millions of dollars, not even for a block. We're talking about, a few homes near a corner of a block that happens to be on the backside, on the west side of Miami Beach as it faces Biscayne Bay. Not only is that costly to the residents there, and they're paying for this, by the way, with an extra fee tacked onto your water and sewer bill, right? So there we go, more carbon taxes. Um, but it's also a study in NIMBYism, because now, because some streets are being raised, some folks are complaining that the water is no longer flooding that street, it's flooding their street, right? Because nobody could raise their street too, or at least it wasn't in the budget. So imagine how complicated that gets, right? Down in the Florida Keys, where they've said, well, we're not going to be able to provide services in these neighborhoods. They've this is even after some appointed officials, in other words, these are political appointees in Monroe County, that actually started to speak about managed retreat, which is walking away from those places that are going to be flooded because of sea level rise. Even after they had the courage to do that and indicate that some neighborhoods would need to be abandoned, now a lot of the money that would have gone to at least save some neighborhoods is being cut, and they're not going to be able to save those. So this has incremental costs. It's only going to get worse as the number of days a year in which streets are flooded continues to multiply.
Thank you, John. Yeah, we've been receiving so many great questions here, and there's been a lot of mention of the different links that you all have shown in your presentations. It would be great if we could compile all of that and send that out in a follow-up email so everyone has that information, as well as the questions that we won't have time to answer. Another question that we received was about building codes. Are they keeping up with the data? It seems like too many new waterfront homes are going up on fill instead of pilings and piers and piers and columns. Anyone care to talk about that?
I can speak a bit to it, but I welcome the others. I wanted to talk about an experience that I had. We did this project with the Northeast Florida Regional Council with Flood Vision. We created photorealistic visualizations of potential future flooding. We presented at a public meeting with elected officials across the political spectrum. It led to a vibrant discussion. It was great. One of the elected officials spoke up and said that these photorealistic visuals could help her and others communicate to the public of the need to update building codes. So there is a need to do that. And I think what we're trying to do at Climate Central is provide tools and visuals to help elected officials and other community leaders kind of communicate that risk and the need for these updates.
I know that Charleston, South Carolina just approved a major development in the floodplain that lies in the 1 in 100-year floodplain near the coast. So development is continuing in areas that are going to flood and eventually we're going to have to retreat from. And there should be a rule that no new development in floodplains, at least no new development that the government will provide mortgages for. So it hasn't stopped yet. We're continuing to repeat our mistakes.
I think I'm just trying to look it up. I think the state of New Jersey passed some measures to prevent building in high-risk areas for flooding, which is innovative of them.
Yep.
I think in some ways, New Jersey is leading the country in planning. In other ways, Florida is leading the country in kind of implementing resilience. And I was just when I was at the Florida Resilience Conference, I heard leading officials mention kind of what Jeff was just saying. We can't afford to keep on building in high risk areas. It's going to cost too much. There's not enough resilience funding later on to go around if we continue doing this.
That's the problem. Sea level rise is hitting the entire coast all at once.
Yeah.
And there's just not enough money to fund all the beach nourishment projects, all the resilience. It's, a tap that's going to run dry, already has run dry.
Yes, yes, unfortunately it has. Oh, right. So we have time for one more question before we turn this over to Shel. John, I think this question would be great for you. Can you chat about the slowing AMOC impacts on SLR, sea level rise for the eastern coast of the USA. So that's the Atlantic Meridional Overturning Current.
Right. I think it's a really good question because it's impacting the southeast and east coast of the U.S. Tremendously, and it's a good reason why Miami's sea level rise is so much higher than what's going on around the rest of the planet. So let's just think about the Gulf Stream, which is part of the AMOC. It's the surface part of the surface portion of the Atlantic Meridional overturning circulation. And the Gulf Stream is indeed slowing down. The speed at which the water, after it exits the Gulf of Mexico and crosses the Florida Straits, squeezes between the Bahamas and Florida, and then offshore the mid-Atlantic states all the way to the North Atlantic, right? That current is slowing down. Less water, therefore, is being evacuated from Florida's and Bahamian, for that matter, coastlines, and with thermal expansion and the melting of the glaciers and the ice caps and so on and so forth, we can't keep up. Not enough water is being removed from this area, and therefore we're seeing sea level rise substantially here. Keep in mind, we've had some of the most severe marine heat waves on record occur in recent years, where water temperatures have even reached triple digits on the Fahrenheit scale, right? That's how hot the water has been down here. Thermal expansion alone is very pronounced in this particular part of the world, and therefore our sea levels are rising so very quickly. So it does have a big impact, and I don't know if others want to weigh in, but without necessarily getting into the weeds about what's going to happen to the AMOC down the road, but it is for now, for sure, impacting us.
Jeff, do you have anything to add to that?
If we were a sane society, yeah, that alone would be enough to drive climate action, but it sure hasn't. And stand up for science, speak up, go to protests. We have to get the word out. And as John has been saying, there are already carbon taxes going on here. It's costing us. We just need to communicate to more people what's going on.
Awesome. Well, thank you all. This has been such an amazing time just to talk about all of these really important weather phenomena that is affecting all of us in some shape or form, especially in coastal communities. So what I'm going to do now is put up on the screen our QR codes for our newsletters. So please do sign up if you have not already. And then I'm going to hand it over to Shel to talk a little bit about extreme heat. And also we will be sending out a follow-up email with some more answers to these unanswered questions, because we received so many great ones. And they're definitely worthy of answering. So Shel, I will let you take it away, if you don't mind, introducing yourself, and I'll throw up on the screen the QR codes, and then we'll go from there.
Sure. Yeah. Shel Winkley, how good to see everybody here today. Even though we're talking about something pretty heavy, pretty soggy. I'm a meteorologist as well as a weather and climate engagement specialist here at Climate Central. And, just listening to everything we've talked about with the impacts of how the ocean plays a role in our life, even if you're not on the coast, right? We are a water planet. We know that 90% of the excess heat that we as humans have caused by burning coal, oil, methane gas, by putting heat trapping pollution into our atmosphere, we know that 90% of that goes into the ocean, right? Our Earth was made to keep this balance, and we have knocked it off course. And the impacts that we have heard here today from Dan is about the expansion of that water. One of the biggest reasons we're seeing a sea level rise because of that heat that is going into our oceans. We heard from Jeff. We heard from John about these storms, right? This no-name storm that is going to cause sea level rise and higher tides there on the coast this weekend. We understand that water temperature is making our storms more intense at times when they come over waters that are well above average. And we have the science to understand just how much more likely a water temperature is because of human caused climate change. We understand the fingerprint of climate change there. So, with that in mind, Pearl, if you want to switch me, let's talk about one thing that Climate Central did. We do this every summer and winter in the global north season, but we looked back at the past 3 months. So again, summer for the global north, June, July, and August. And we wanted to use attribution science to understand how did heat impact us? How much extra heat do we experience across the globe during this 3 month period? And how much more heat do we experience that is harmful to our health? Potentially. And attribution science, if you're not familiar with it, essentially what this is saying is it's not to necessarily say that climate change caused this heat, but it did make it more likely. And to understand how much more likely, and if heat like that could have been rare or almost virtually impossible without climate change. So some of the high level things that we found as we put this report together: 1 in 5 people worldwide, so we're talking about 1.8 billion people every single day from June through August, felt a strong climate change influence on the temperature that they walked outside their door to. So for the climate shift index, which is a scale from 0 to 5, that's a 2 or higher. So 1.8 billion people walked out the door every day in this 3 month period with heat that was made at least twice as likely due to human caused climate change. About 955 million people endured a month or more of what we call risky heat. So risky heat is defined as the 90th percentile temperature. Think about this as the hottest of the hot temperature that you expect to feel during these 3 months. 90% of those temperatures were made worse because of climate change. We had a month extra of this heat that can impact our health, especially for the younger members of our community, the elderly, and then those with pre-existing health conditions. An extra month of heat during this time period that could put them at danger. 183 countries and 553 cities, the average person faced 30 days or more. So again, a month or more of heat strongly influenced by climate change. And this was specifically pronounced in Asia. Cities in Europe and Asia really helped us to understand, we're talking about these rising sea level impacts to our cities. We also understand that cities are some of the places that get hit the hardest when it comes to heat because you have climate change's impact. And then you have the urbanization, the urban heat island effect that comes along with it. Europe and Asia especially experienced the most unusual heat this summer. So let's drill this down to the United States. Here's a look across. And again, this is risky heat. So you can really pick out the desert Southwest, the Four Corners region, Texas, Louisiana, Florida, Puerto Rico, portions of Hawaii, and even southern portions of Alaska. We're dealing with heat that was potentially dangerous to their health during the summer months. 193 of our 247 US cities that we analyzed had at least a week of days that were strongly influenced by climate change. So that's at least 1 week where temperatures were made twice as likely to be hotter than average, even in the summertime due to climate change. 21 million Americans or more faced that month of hot, risky heat. And 112 cities, half or more of those risky heat days were linked to climate change. So we could say this day that you felt and that was dangerous because of that heat when you're outside, we understand that climate change played a role and made that heat more likely. Some of the risky heat when we look at our cities specifically, just to point out the cities that had the most climate influence this summer, it was Honolulu, San Juan, West Palm Beach, Miami, and Tampa, Florida. So we understand that mostly in the South and the West is where we felt most of the climate change driven heat. But when we talk about the risky heat days, you can see the list there of the cities that were impacted the most, and most of those cities are the same: West Palm, Anchorage, Miami, San Juan, and Salt Lake City. And so what we can do from there is look at this day by day. We can use the climate shift index and give you a day by day breakdown to say, okay, we understand how much more likely this heat was made because of climate change. So for West Palm Beach specifically, of those 50 days, you see those darker maroon red colors. That's where we had heat that was made 4 times or 5 times more likely. So that's where, if it's a 4, think about that as heat that would be rare without climate change. It would be really hard to get that if we didn't have a fingerprint of climate change. A 5, again, that's where it becomes almost impossible to experience a temperature like this. And again, even in West Palm, even in summertime where we expect temperatures to be pretty hot and sultry, we understand that that level of heat would be almost impossible without climate change. So you can see how many climate change driven days were there in West Palm Beach. You can see Miami. Notice that there are some bars that go south that are gray and pointed down. Those are temperatures made less likely because of a warming world that we expect to experience less in the summer months. And that's because we likely had a strong tie to a rainy time during those periods. It takes that in order to bring down temperatures and give us these unusually cool temperatures in the summer months. And then in San Juan, you can see all of the days. Notice that most of them are maroon. A lot of the heat that was felt in San Juan this summer was made almost impossible because of climate change. And there's a connection to the ocean temperatures as well. If you look at the water temperatures around the island of Puerto Rico, those water temperatures are made significantly more likely because of climate change. It's a feedback loop. The land heat influences the oceans around it. The ocean heat influences the heat that you feel on the island itself. And that's one area that we've seen climate change really have an impact. So what's great about this report is you can really understand, again, risky heat is a thing that comes with weather. It comes with summertime. But we also understand that there were more days. You're looking at a map of risky heat that would have happened this summer, even if we had a world that didn't have this excess carbon pollution. And this is what the map looks like in our world that we live in with the climate change influence. So for the United States, this summer, we can quantify to say without climate change, on average, the United States would have experienced 18 risky heat days. But with the human influence of climate change, that heat trapping pollution, we added 20 days as a human species to the dangerous heat that we had on hand this summer. So I'll leave you with these two QR codes. We may put this in the chat as well. The QR code on the left, that's going to be the US focused data, as well as the visuals that you can share, that you can use. And the one on the right is going to be the global data. And it has that interactive map that you can go through. You can select your counties. You can see the data in real time as you use it there on your screen. So a little breakdown for you for the past summer months. And I'll just leave it with hopefully we can finally get to fall weather. I know parts of the country are starting to get there. I'm down south, so we haven't got there quite yet. But we also know that the summer heat is lingering and creeping into the beginning of the fall season.
Well, thank you, Shel, for that. That is both amazingly displayed data, but very scary at the same time. Anyways, well, thank you, Shel. Thank you to all our panelists, Dan, John, Jeff, for your time, for your knowledge. Also, a big thank you to our audience today for being here. We know all of our time is precious, so thank you. And in the next couple of days, you'll be receiving an email with a link to this video and links to all the slides the information that was presented on the slides, as well as answers to the questions that we couldn't get to today. Thank you for sending in those questions. All of them were super interesting. And yeah, we'll have a great rest of your day. Thank you.